In this video, we will define superposition, which is a property of linear circuits. We will begin with a definition of linear element. All elements are expected to have a response, which is a function of the input. And we will write this mathematically as an equation. For example, a resistor has the equation that the voltage is equal to R times the current. In this equation, we can take the current to be the input and the voltage to be the response to the input. In a mathematical form, we will say that the input I generates a response V. An element is linear if it satisfies two properties. If the input I1 produces a response V1 and the input I2 produces the response V2, then the input I1 plus I2 will produce a response V1 plus V2. This property is called superposition. The second property that a linear element must satisfy is that if the input is I1 and the response is V1, then an input of K times I1 will produce a response K times V1, where K is any constant. These two properties are satisfied by the linear resistor V is equal to Ri, and also by all the control sources that we have studied in this course. For example, a voltage-controlled voltage source, which has the input as the input controlling variable, which may be Vx with the polarity given, and the control source has a value which is K times the controlling variable, or Kvx. For the voltage-controlled voltage source, we can consider Vx to be the input and the control source Kvx as the response. Therefore, all the elements that we have studied in this course are linear, and we will leave the analysis of nonlinear circuits for a different course. We are now ready to give a description of superposition. A circuit must satisfy three conditions before superposition can be used. The first condition is that the circuit contains linear elements only. The second condition is that the input to the circuit consists of independent voltage and current sources, for example V1, V2 and so on for the independent voltage sources, and I1, I2 and so on for the independent current sources. The last condition is that the variables to be computed are currents or voltages in the circuit. This is considered the response of the circuit. Note that power is specifically excluded from the variables that can be computed using superposition. If a circuit meets all of these conditions, then superposition states that the response V0 will be a linear combination of the inputs, such that it will be equal to alpha 1 V1 plus alpha 2 V2 and so on for all the voltage sources, plus beta 1 I1 plus beta 2 I2 and so on for all the current sources, where alpha I and beta I are constants. We will interpret this result in detail. Suppose only the input V1 is non-zero and all the other inputs are zero, which means that V2 is equal to V3 and so on is equal to 0, and similarly I1 is equal to I2 and so on is equal to 0. If we substitute these values in the above equation, we will get VO is equal to alpha 1 V1. We will attach a superscript of V1 to the output VO to indicate that this is the output due to the input V1 only. Similarly, we can define VO with the superscript of V2 is equal to alpha 2 V2, where only V2 is non-zero and all other inputs are equal to 0. This procedure can be continued to calculate the output due to one input only at a time. Substituting all of these values into the original equation, we will get V0 is equal to V0 due to V1 only, plus V0 equal to V2 only, and so on, and plus V0 due to I1 only, plus V0 due to I2, and so on. This tells us that the total output is the sum of the outputs due to individual input voltages and current sources, and we will make use of this in the analysis of electric circuits. Before proceeding with an example, we will consider in detail what is meant by making the independent voltage or current source value equal to 0. Recall that in superposition, we have only one non-zero input source and all the other sources are equal to 0. For example, we have V1 is not equal to 0 and we have V2 equals to V3 and so on is equal to 0, and also I1 is equal to I2 and so on is equal to 0. When the value of a source is non-zero, we say it is on or switched on, and when the value is 0, we say that it has been switched off. Also recall that when a voltage source has been switched off or its value is equal to 0, we say that it is replaced by a short circuit. And when a current source is switched off or its value is equal to 0, it is replaced with an open circuit. We will now solve an example circuit using superposition. The circuit shown contains two independent sources, one independent voltage source and one independent current source, and assume that we are interested in the output current through the 4 ohm resistor, and we will call this I0. We begin by switching on only the 10 volt source and switching off the 2 ampere current source. Switching off a current source means replacing it with an open circuit, and the circuit that we will be left with will be we will put a superscript of V on the current I0 to indicate that it is due to the voltage source only. The analysis of this circuit is straightforward, and we can write down I0 of V will be equal to 10 volts over 4 plus 4 ohms, which will be equal to 1.25 amperes. Next, we will switch off the voltage source and switch on the current source. The circuit will now look like and the current, which is the response that we are looking for, I0 with the superscript of I, to indicate that it is due to the current source only. We can identify this circuit as a current divider, and I0 of I will be equal to minus 4 over 4 plus 4 multiplied by 2 amperes, which will give us minus 1 ampere. Adding both of these results will give us that I0 is equal to I0 V plus I0 I, which is equal to 1.25 minus 1 is equal to 0.25 amperes. We will leave it as an exercise for you to solve the original circuit directly without using superposition and check the result for I0 is correct. To summarize, when we switch on the voltage source, then all the currents and voltages in the circuit are the response to just the voltage source. And when we switch on only the current source, then all the voltages and currents are the responses to that current source. And if we switch on both the current and the voltage sources, we combine the partial results and we get the overall response, which will be the sum of the individual responses.